Hello. Thank you for tuning in to Affiliated Engineers Inc.'s ACE RDU session on MEP engineering and how it relates to this year's Ideal High School project. My name is Hunter. I'm an electrical engineer and I'm joined by other young professionals from AEI. You'll hear from Abby, a mechanical engineer, Nicole, an electrical engineer, and Tim, a plumbing engineer, as we discuss the MEP systems in an ideal high school and how they apply to the project. MEP stands for Mechanical, Electrical, and Piping and Plumbing Engineering. As we dive into MEP engineering systems, take a look around the room and notice the systems at work. The comfortable room temperature is due to mechanical engineering. The lighting and power are the result of electrical engineering. Any sinks and water fixtures are thanks to plumbing engineering. MEP engineering is not only the placement of the devices, fixtures, or appliances, it is the design of how to distribute air, power, and water throughout the building to those end-use points. MEP engineers work closely with architects and construction managers to meet clients' needs efficiently. Take a look at this short fly-through video showcasing some of the innovative MEP engineering systems AEI designs. In this video, we will introduce AEI, describe the role of a consulting engineer, discuss the steps to design an MEP system in a building, review current renewable energy measures in MEP systems, review a building case study, and share some additional advice you might find helpful in building an effective system for your building design. AEI is a full-service MEP firm with 22 office locations across the country and more than 900 employees. Although all of the engineers you will hear from today are based in Chapel Hill, we also work on many projects out of state. In addition to mechanical, electrical, and plumbing engineering, AEI offers a range of services including commissioning, fire protection engineering, building performance design, and specialty lighting design, just to name a few. AEI designs engineering systems that create clean, controlled, and safe environments for diverse facilities, including healthcare, research, industrial test, and more. You'll hear from engineers who specialize in building design, spanning research buildings, hospitals, universities, and energy and utility infrastructure. Some local projects you might recognize include UNC Chapel Hill Genome Sciences Building, East Carolina University Life Sciences and Biotechnology Building, Wake County Public School System Fuquay-Varina High School, while not designed by AEI, was commissioned by AEI, which is making sure all of the MEP systems in the building operate as intended. We are consulting engineers, professionals who collaborate directly with a team to provide expert recommendations and address client needs while adhering to design standards. Much like your role in working with a client for your ideal high school, our team partners with project owners early in the design process. We remain involved throughout construction to ensure every element is installed accurately and meets expectations. Throughout the design process, each type of engineer is responsible for integrating several systems into the building. The mechanical engineer oversees the design of HVAC, or heating, ventilation, and air conditioning systems. This involves analyzing the building's layout, selecting and sizing equipment, and designing duct layouts to deliver conditioned air to specific rooms, ensuring occupant comfort. The electrical engineer handles power, lighting, and systems design. Their role includes coordinating with the other engineers and architects to provide electricity where needed, designing lighting and control systems, and strategically placing fire alarm devices to ensure safety in case of emergencies. The plumbing engineer is responsible for designing hot water, cold water, sanitary, and ventilation systems. This involves selecting and sizing equipment, determining pathways to distribute water from the building entry point to fixtures, and ensuring proper wastewater removal. Given the complexity of their individual responsibilities, MEP engineers must work closely with one another and project partners, like the architects. Clear communication is essential to ensure all systems are seamlessly integrated and constructible. Next, we'll take a closer look at each of the MEP systems and explore key considerations for designing them in your project. To get us started, let's head it over to Abby for an introduction to MEP engineering for large buildings.
When engineers are doing these system layouts, they are tasked with thinking through and designing three-dimensional systems using building models and producing plans for those designs in two-dimensional construction documents. On the screen, you'll see a BIM or Building Information Model of a new veterinary medicine building, MEP designed by EEI, that is currently in construction. This model allows us to work with architects and structural engineers in real time to coordinate systems within the building. The 3D isometric view shows how all of the systems are routed around each other. Removing the roofs and some exterior walls on the ISO view allows us to see the interior components. While this building is not the same program as your project, it is similar in scale to the high school you are producing. It houses classrooms, teaching, office, and support spaces. Once we remove the non-mechanical systems, we are left with everything related to the building design of heating, ventilation, and air conditioning systems. The building HVAC system consists of the air handling system, general exhaust system, and individual zone terminals, such as VAV air terminals, chilled beams, and unit heaters. The mechanical system size is important to provide occupant comfort and is dependent on the square footage, fenestration, heat rejection from equipment or appliances, and latent load from occupants. The air handling system includes a factory fabricated air handling unit, or AHU, shown in yellow, located in the building penthouse. This unit takes in outside air, conditions it, and provides heating, cooling, and humidification control to the spaces. The air is then exhausted outdoors with no air returning to the air handling unit. It is important to consider a clearance zone around the equipment to allow for standard maintenance procedures. Supply ducts shown in the cyan-colored lines take conditioned air from the unit and move it to different spaces in the building. Vertical main risers distribute at each floor level, and then branches run to individual spaces. Exhaust ducts shown in the darker blue lines remove air from the space. Similar to the supply, there are return vertical risers and branch ducts. This is important to maintain neutral pressure in the building. The building also includes a chilled water piping system, shown in blue, and a heating hot water piping system, shown in green. The chilled water and heating hot water is generated in a campus utility plant and brought to the building by underground piping to the mechanical room on the ground floor. The underground piping enters the building and connects to pumps. The chilled water pumps distribute cold water to supplemental cooling devices such as chilled beams and radiant cooling panels. The heating hot water pumps distribute water to air handling unit coils, chilled beams, and unit heaters. Chilled beams and cooling panels aid in increasing energy efficiency in the building. It is important to remember that this water piping system aids in conditioning the space and is separate from water provided to plumbing fixtures. These elements are the basics for laying out a mechanical system in your building. To review the steps for laying it out, first, select main equipment locations for air handling units and pumps. Second, determine supply duct mains, and then the return duct mains or exhaust duct mains. And then consider sustainability strategies. Good luck on the mechanical design, and I'll turn it over to Nicole to discuss laying out the electrical system.
Hi, I'm Nicole Rink, an electrical engineer at AEI, and I will be discussing the basics for laying out the electrical system in your building. The electrical system in a building is very vital to occupant comfort, and it provides power to the mechanical and plumbing systems, lighting systems, appliances, and any visual displays. First, you must determine where on site your power is coming from. The utility provides power to the building, and then this power enters a transformer. This transformer is typically located at the exterior of the building, and its purpose is to step the voltage down to a voltage that is usable by the large equipment in the building. Located adjacent in the utility area, there's also a generator. This generator provides a backup source of power should there be a power outage. Power is then brought into the main electrical room and into the main switchboard. The main switchboard acts as a large central panel before the power gets distributed to other areas of the building. Power is distributed in the building through wires and conduit. Conduit is a pipe that holds and protects the wires. Power is distributed from the main switchboard to branch panel boards. When placing branch panel boards on a floor plan, you should consider locating them close to the loads they will be serving. Typically, they can serve loads within a 100-foot radius. The panels are wall-mounted and need to maintain 3 feet of clearance in front. Typically, they are located in dedicated electrical closets, but they can be in public areas if they are locked. From the branch panel boards, conduit and wire, shown in lavender, are run to various devices in the building to provide power. Mechanical, piping, and other equipment will need to be powered. It is important to coordinate the equipment requirements with the mechanical engineer and piping engineer to make sure the wire and circuit breakers are sized correctly. Now we are going to zoom into a classroom and look at individual devices. The building will need receptacles along the walls, shown in orange, for plugging in displays, appliances, laptops, phone chargers, and other electronics. It is important to have enough receptacles to meet the occupants' needs. To connect the equipment and receptacles to your panel, conduit and wire will be run in walls. Another important item that needs to be powered is your lights, shown in blue. Typically, lighting is fed from a dedicated lighting branch panel board. There is a wide range of light fixture types to choose from. You can go with simple recessed down lights to hide the fixture, or something fancy like a pendant mounted chandelier. There are also special wet and exterior rated light fixtures to use in locations such as showers or outdoor patios. There is no wrong choice when it comes to light fixture types, as long as there is enough light and it is evenly distributed in the room. The lights will also have another connection to a light switch or other control device. There are multiple options for lighting control. For example, the switch could be an on-off, dimmable, or a specific scene could be set. This allows for flexibility in different spaces in the building. In the event of a fire, detection needs to be provided so that building occupants can stay safe. This building has the main fire control panel located in the main electrical room. Through programming, all of the fire alarm devices are monitored on this panel. Fire alarm devices can fall into 2 different categories: detection and notification. Detection devices like smoke detectors and pull stations send an alert to the fire alarm control panel that there is a fire. The fire alarm control panel then commands the notification devices to operate. The notification devices like speakers and strobes send visual or audible signals across the building so that they know they need to exit. All of these elements are the basics for laying out an electrical system in your high school. To review, the steps are: 1. Determine where power is coming from on-site. 2. Select main equipment locations for the transformer and switchboard. 3. Select locations for your branch panel boards. And 4. Consider layouts for receptacles, equipment, and lights. Good luck on your electrical system design. I will turn it over to Tim to discuss laying out the plumbing system.
Hello, I'm Tim Civic, a plumbing engineer at AEI, and I will discuss the basics for layout of your plumbing system in your building. The plumbing system in the building consists of hot water distribution, cold water distribution, waste and vent systems, and a stormwater drainage system. From the utility plant, the building will receive a water connection. You must select where you want the water connection to enter the building and where you would like drainage to leave. Once you know where the water is entering and leaving, you must determine where your piping fixtures are located and what service should be provided to each of them. Cold water, shown in cyan, enters the building into booster pumps located in the mechanical room. It is then distributed to sinks, showers, toilets, and other fixtures as required through piping running in the ceiling. Hot water, shown in red, is heated in the mechanical room by water heaters to 140 degrees Fahrenheit to prevent growth of bacteria. 140-degree water is then mixed with cold water at a mixing valve to bring the temperature down to 120 degrees to prevent scalding. It is then distributed to all fixtures and devices that require hot water. When placing the pumps and water heaters, be sure to leave clearance so the equipment can be serviced if there are any maintenance issues. Exact equipment clearances depends on the equipment manufacturer. Sanitary waste and vent systems are required to remove the hot and cold wastewater being provided. Plumbing fixtures are drained by gravity through stacks and building drains to the building sewer system. The sanitary piping, shown in magenta, connects the drains from the sinks, showers, toilets, and floors and routes wastewater out of the building and to the utility. The storm drainage system takes rainwater from flat roofs to the building storm sewer. Gutters transport rainwater on the roof and use gravity to bring it down the building to the dedicated location. When designing piping systems, keep in mind that sanitary waste and vent pipes must be sloped to properly distribute. Hot and cold water distribution does not have to be sloped. All of these elements are the basics for laying out your plumbing system. To review, the steps are: 1. Determine where the utility connections are. 2. Determine where your plumbing fixtures are. 3. Determine locations for pumps and water heaters. 4. Consider piping layouts. And 5. Consider how rain will drain from the roof. All MEP, mechanical, electrical, and plumbing systems work together to keep the building occupants safe and comfortable. It is important for engineers and architects to work with each other in order to effectively route systems in the building. As you begin laying out your systems, consider where the main equipment will be located and where the utilities have to end up. The mechanical plan should locate the main equipment and show the main supply and return ductwork. The plumbing plan should show water and sewer entry, the water heater, pumps, and main hot and cold water routing. The electrical plan should show the transformer, power entry switchboard, and branch panel boards. While this video gives you the basics on what composes an MEP system, there are also other renewable energy that you can consider for your school design. Back to you, Hunter.
Several current trends in MEP system design could be applicable to your high school project. Many of these trends focus on sustainability, which was covered in an earlier session. Exploring these topics further may reveal opportunities to enhance the efficiency and functionality of your design. A notable mechanical sustainability trend is radiant heating, which involves warming a space by transferring heat through building components, such as walls and floors. This method offers both energy efficiency and acoustical advantages, making it an excellent option for sustainable design. An important electrical sustainability trend is solar photovoltaics. This technology harnesses solar energy through photovoltaic panels, which capture sunlight and convert it into electricity to power a home. A key plumbing sustainability trend is rainwater harvesting. This system collects water from a home's roof and stores it on-site for future use, promoting water conservation and providing a backup water source during emergencies. These sustainability features represent just a fraction of the many elements you could incorporate in your high school design. Take some time to research different options to determine the best solution for your design. Whether you are working as an architect, engineer, or construction manager on a project, collaboration is key. Providing recommendations and aligning efforts toward the client's common goal ensures success. When designing mechanical, electrical, and plumbing systems, it is important to understand how these systems relate to architectural design and building construction. So start by reviewing the architectural plan for your building and identify the necessary MEP systems for each room. Consider the best locations for the main equipment and how the systems will connect from the equipment to their intended location. One challenge to address is optimizing the floor plan to accommodate these systems effectively. As a team, consider dividing responsibilities for the engineering aspects. The mechanical engineer would assess heating and cooling requirements. The electrical engineer would design the power and lighting systems, and the plumbing engineer would ensure the appropriate utilities support plumbing fixtures. Additionally, explore any client preferences that can be incorporated through design. While there will be challenges, working together as a team will help produce a complete building design. Thank you for tuning into our video, and best of luck with your ideal high school project.